Do this sample test here on chapter 6. And this will be my second go at this because I messed up a few problems on the first one. So find the area enclosed by these curves. I'm going to draw these two curves. And this is in the first quadrant. So let's see. If I put in 1, I'll get 4 over 1, 4 minus 1, which is 3. If I put in 2, I get 2 minus 1, which is 1. And if I put in 4, I get 0. So this first one looks something like this. The second curve, if I put in 0, I get 4 over 4, which is 1. 1 minus 1 is 0. So if I put in 0, I get 0. If I put in 2, 2 minus 2 is 0, so I get 1. And if I put in 4, 4 minus 2 is 2, squared is 4, so I get 1 minus 1, which is 0. So the area between the curve is in here, in the first quadrant. So it's going to be the integral from 2 to 4 of the higher curve, which is this one, minus the lower one. Okay? So we're going to work this integral out. So we got a 1 and a minus 1. They cancel. And this would be x squared. I'll just do it out. X squared minus 4x plus 4. And then a minus on all of those. Divided by 4. Minus 4 over x. And so these 4's would cancel. The integral of this would be 3, and put a 3 down there, so it'd be minus x to the third over 12. And x, that would go to x squared over 2. Minus 1 would be minus x. And this would be minus 4 ln of x in absolute value. Evaluated from 2 to 4. So 4 cubed is 64 over 12 negative, and 16 over 2 is 8, and that would be minus 4 minus 4 ln of 4 minus 8 twelfths. 2 squared is 4 over 2 is 2 minus 2 minus 4 ln 2, which is positive, so I don't need the absolute value. And then we can see minus 2 and 2. Let's see, 8 minus 4 is 4. 4 goes into both of these. That's 6 minus 16 thirds plus 4 minus, see, 4 goes into both of those. minus 2/3, and then I've got minus 4. I'll make it plus 4 because this is plus 4, so then it's going to be ln of ln of 2 minus ln of 4, which is minus. And when you subtract ln's, you get division. This is a plus. This minus makes that a plus. So we got 2 divided by 4, which is 1/2. ln of subtracted turns into division. So 16 minus 8, so that would be minus 18/3, which is minus 6, plus 4 is minus 2 plus 4 ln 1/2. Okay. There's more I could do, but that's, if I haven't made a mistake, that's hopefully correct. Okay, find the volume of a solid rotating the area in the first quadrant. This is the cosecant, which is the reciprocal of the sine. So it's going to go something like this. They touch right there, asymptote there at pi and 0. This sine is 0. And it says to do it between pi over 6 and 2 pi over 3. So we want this area, rotating the area about the x-axis. So we're going to get, probably discs would be the easiest on this, which are pi integral of r squared, which is going to be y squared, pi r squared. Thickness is dx, evaluated from pi over 6 to 2 pi over 3. And so y is equal to the cosecant of x. So we've got the pi integral from pi over 6 to 2 pi over 3 of cosecant squared x dx. And looking at the last page, we can see that derivative of cotangent is negative cosecant, so there'd be negative cotangent if I integrate it. So this would be pi negative cotangent of x evaluated from pi over 6 to 2 pi over 3. Cotangent, just thinking about the unit circle, cotangent at 2 pi over 3, cotangent's cosine over sine, so that's 1 over the square root of 3. So we got pi over the square root of 3, and that would be negative. Cotangent's negative there, and a negative, that makes this positive. Minus and pi over 6 is here. The cotangent would be square root of 3 over 1 times pi. And that would be minus a minus, which is plus. Nope. Yeah, we got to subtract this one, and it's a minus already. And the cotangent here is plus, so minus a minus is plus. So that's answer there. That's good enough. City population density. So as you go out from the center in rings, each of the ring will have so much area, and you take the area times the density of that area, and you get the population on that ring. Ring width will be dr, because we're changing the radius. The area of the ring would be the length around the ring, which is 2 pi r times the width of that ring, which is dr. So there's the area. But we got to take it times, so in here, we need to put the density function. The number of people per square kilometer on that area. So this becomes, and we're going to integrate this from within 5 kilometers. So we're going to integrate it from 0 to 5. And I forgot the 2 pi here. 2 pi r times the density. Let's take the eraser out here. Since I'm doing this in pencil, I can fix this. 2 pi, there's a constant of 500. Need the r, the rest of the density function. dr. So 2 pi r dr is the area times the population per square area. And we're going to integrate this from 0 to 5. So I'm going to let u be this. U be the 1 plus 0.16 r squared du equals 0.32 r dr, and so I'm going to divide by du by 0.32 r, and that will be dr. That's what I'll replace dr with, and so this is going to be 1,000 pi integral from, let's see, now if I put 0 in here, I get 1. And if I put 5 in there, 5 squared is 25. 25 times 0.16 is, where'd my calculator go here? Here. $25 times 0.16 is 4. 1 plus 4 is 5. It just accidentally happens to be the same top. And then we're going to have r, which we're hoping will disappear here. And this, which is going to be u to the minus 1. dr changes to du over 0.32 r, and so there's the r's canceling. So we have u to the minus 1, which is 1 over u. That integrated becomes ln, so we've got 1,000 divided by 0.32, which is 3125 pi. So I took this out and put it into that. And ln of u evaluated from 1 to 5. So this becomes 3125 pi ln 5. And then if I put 1 in here, ln of 1 is 0, so minus 0. And so my population is going to be 3125 times pi times ln 5. 15,800. Okay, page 2. I really messed up on the first video, so I'm redoing this one. Okay. Set up an integral equation that would find the volume of created rotating around the x-axis. So I'm going to make the x-axis here. And I'm going to make it be, the y-axis be here. And I'm going to make it 1, 2, 3. 1, 2, 3, x plus y equals 3. We'll go through a y-intercept of 3 and an x-intercept of 3. And this one would go through plus 1 with a slope of 1. And y equal 1 would be here. And so here's the enclosed region. And it's spun around the y-axis, or the x-axis. So I was adding 1 in my original video, but I shouldn't be. Now it says set up an unintegral equation that would find the volume created by doing rotated using the disk method. So we would have to be doing slices vertically. So there'd be that one up there and one down here. So, and they'd be washers. And we're going to have the thickness of the washer is going to be dx. So we're going to have and these washers are going to be 2 circles, and we're going to have to do the area of the circle, which is pi r squared. Large radius is simply x plus 1 minus the smaller radius, which is just y equals 1. Large radius minus small radius. And that would work for from here to there. So from 0 to 1. dx. But then we would have to add for the discs over here, which are not going to be limited by this line, but by this line. So that would be the integral pi from 1 to 2 of the large radius will be up to here, which is going to be 3 minus x minus the inside radius, which should be 1 squared. Now, we can clearly see that this is the same as this, so we could have just taken the first one and doubled it by the symmetry and gotten the volume of the ring. So we could say this is just 2 pi integral from 0 to 1 of x plus 1 squared minus 1 dx. And x plus 1 squared is x squared plus 2x plus 1, and then minus 1 would cancel that, dx, integrated from 0 to 1 times 2 pi. So if I integrate this, I'm going to get integral from 0 to 1 times 2 pi. Why do I get 2 pi? Oh, because we're doubling it. That would be, integrating it, it would be x to the third over 3, and putting in 1 in here, we get plus, or integrated, that'd be plus x squared, evaluated from 0 to 1, so that'd be 1/3 plus 1, which is 4/3. 4/3 times 2 pi minus, we put in 0, we get nothing, and so we get 8 pi over 3. But all it said here was to set up the integral, so I would have been fine with this or with this for the disk method. Now if we do the ring method, this shell method, we're going to make shells that are this way, that go around and they go in the back, and we're going to have a thickness on them of dy. So let's work out these. So that would be the integral, and so we're going to doing dy's, and we're going to have a radius that's y. So the distance around is 2 pi r times this, which is going to be this curve. It's going to be y, the difference in these two y's. So this y here, and we have to do it in terms of y, is going to be, y for this one is going to be equal to, let's see here, I want to do it in terms of y, or x. This direction is x, and x is 3 minus y. So the large x is 3 minus y minus this one, which is an x on this one. X would be y minus 1. So that's how long this is. The difference in the x for this equation and the x for this equation. And that's the height of this ring, if you think, or the width of the ring, if you will. And the distance around the ring is 2 pi times y, the radius. And the thickness of all that ring is dy. And we're going to integrate for y going from 1 to 2. So that would be the setup on the second one here. And then C says use calculus methods to either solve this one or this one. Well, I did this one, but I'm going to do this one too, just to make sure I get the same answer. I wouldn't do both of them on the test because you wouldn't have time. From 1 to 2. So 3 minus y, so that's minus 2y's. And 3 minus a minus 1 is 4. And I take it times y, so I got 4y minus 2y squared dy. And that would be integrated would be 2y squared, and this would be minus 2/3 y to the third, all this times 2 pi, integrated from 1 to 2. Evaluated from 1 to 2, so we're going to put in the 2, and that would give us 8. And put in the 1, we get 2 minus 2. Oh, wait a minute. Put in the 2, I get 8. And this would be 8 times 2, 16/3, minus 16/3, minus, now we put in the 1, and I'd get 2 minus 2/3. So minus 16/3 plus 2/3 is 14/3. I'm worried that I didn't get out. Oh, I got 8/3. Okay, so it could be right. And then we've got 8 minus 2, which is 6. Minus 16/3 plus 2/3 is minus 14/3, 2 pi. And 6 is 18/3. So we've got minus 14/3 plus 18/3 is 4/3. Which would be 8/3 pi. Oop, I did all that where you couldn't see it. Sorry. So I got this, I integrated it, I was talking about it, and then I plugged in the 2 and I got this mess, and I plugged in the 1, got this mess, and I worked it out and I got the same answer as I did up here. Okay, so you can look at that and see what you're doing there. Okay? All right. 5, it says, derive the formula for the volume of a hemisphere with the radius r. So that would be r. So in this direction, since it's a hemisphere, would also be r. And the volume. Well, I think I would slice this horizontally to make a disk, because slicing it and this way, doing the shell, I could do it shell too. It could be done with shells. They would be something like that. I'll just do the disk method. I think I did both of them on the first video. Let's go ahead and do both of them here. So first of all, if I do the disk method, this radius is not this radius. That's the radius. If I make this the y-axis, that would be y. This would be x. And the formula for a circle that has a radius r is x squared plus y squared equals r squared. So this is r. So if I do the disk method, the thickness would be dx, and I would have integrate x, dy. This is the thickness vertically, so dy. And I'd integrate y from 0 to r. 0 to r dy, and it's going to be pi r squared, but the radius here we're talking about is x, so it's x squared, and x squared is equal to capital R squared minus y squared. So it's pi r, or x squared, which is this expression, because that's exactly what x squared is, dy. So now we integrate this, we get pi integral of r squared. That's just a constant, so it's going to be r squared y. And then integrate that would be minus y to the third over 3, evaluated from 0 to r. 0 gives me nothing. I put r in here, and I get pi r cubed minus r cubed over 3. So 3/3 minus 1/3 of r cubed is 2/3. 2 pi over 3r cubed. And that's the correct formula for a hemisphere. Now let's do it with the shell method. So then the d would be dx. In the shell method, it's the circumference, which is 2 pi r, and the r would be x, times the height, which is y. But instead of y, I want to use, that would make it be r squared minus x squared square root. That would be y. And we'd integrate this x from 0 to r. And this is all in terms of x. I would let u be the inside. And so du would be 2 minus 2x dx. So du divided by minus 2x would be dx. So I'm going to have 2 pi integral from, I'm changing to u, so if I put 0 in for x, I get r squared. And if I put in r, I get r squared minus r squared, which is 0. X, this would be square root of u. And dx is du over minus 2x. X's cancel. Minus 2 comes out. And so I have minus pi, because those will cancel. Got a minus and a pi. And integrating u to the minus 1/2 would be 2/3 u to the 3/2 evaluated from r squared to 0. If I put in 0, I get 0. Minus a minus pi. And then I put in r squared. Square root of r squared is r cubed. So I get 2/3 r cubed, which is the same answer as we had before. Okay, number 6. The work done by a person standing on a roof, leaning over here, trying to pull something up, and it's a rope tied to, that is that much weight, tied to the bucket that's down here on the ground, that has a 20 kilogram mass. So we're going to lift that 20 kilograms. It's not going to change all the way up, so we can figure out the work on that. So work is force times distance. And a force will be weight, which is, or force is mass times acceleration. And since we're working against gravity, the mass is 20 kilograms times the acceleration due to gravity is 9.8. And that would be the force. And the distance that's going to go is the height of the building, which was 5 meters. So 5 times 20 is 100, times 9.8 would be 980 kilogram meters per second is a Newton, times meters, a Newton meter, which is a joule. That's just to lift the bucket. This person also has to lift the rope, but the weight of the rope is decreasing. So if we just take a little chunk of the rope here, call it dy, because this is vertically. And how far do we have to pull this little chunk up? Well, it could be called y. So we're going to figure out lifting this piece of the rope. So its weight will be the mass. Well, we don't know the mass. The mass depends on how big it is. So it's 0.05 kilograms per meter times how long that piece is, which is dy meters. And so those meters are going to cancel. So that would give us the mass of this little piece. And we have to take the mass times the acceleration, so times 9.8. So now we have the force, and the distance it has to go up is y, so we got to take that times y, and we got to lift it, this piece, and we got to lift all the other pieces, which are going to be all the pieces from y being 0 to y being 5. So this becomes 9.8 times 0. 9.8 times 0.05 is 0.49 constant can come out, 0.49. Then we'd have y dy, so that integrated would be y squared over 2, evaluated from 0 to 5. And so then we would get 5 in here be 25 over 2, which is, we're going to have 0.49 times 25 halves minus 0. So we're going to get that times 25 divided by 2. It's going to take 6.125 joules to lift the rope, 980 to lift the bucket, so a total of 986.125 joules to lift the rope and the bucket. Now you could have kept the bucket in the integral. That would have been a mass. This is the mass here, and to that mass you would add, so it could have been the integral from 0 to 5 of y times the mass of the bucket plus the mass of the rope times 0.05 dy. I'm messing up. I'm not going to do that way. I'm going to leave that alone because I think that's all right. Okay, so then, last one. Determine the work pumping the water out of the top of a tank. So, we'll take a slice, and we have to lift at the top. The tank is 9 meters tall, and the radius is 3 meters because the diameter is 6. So this volume of that is going to be, let's just say dy because it's in the y direction. So it's dy times r squared pi. Pi r squared dy is the volume. And the volume times the density of water. Density is, the water is 1,000 kilograms per meter cubed. These are in meters. And that would be the, so this times that would cancel the meters cubed, and that would give you the mass. Then we'd have to multiply by the acceleration due to gravity. That would give us the force. And then we have to take the force times the distance. So if we call this y, that we have to lift it, we'd have the integral as y goes from 0 to 3, 0 to 9, of pi r squared times 9.8 times 1,000, which is 9,800. That would be the weight of the water times the volume, which is pi r squared dy times the distance, y. So density times the volume. These three give you the volume times the distance. So that would be the weight when you take the density times gravity, and the density and gravity times the volume will give you the weight times the distance you got to lift it. So now we got to get r out of there. This is r. And if I put y here, this makes it an easy one to do. I'd say y, want to find r here, so I'll say r is to y as 3 is to 9, so I can multiply by y, and r is just 1/3 y. So r squared would be 1/9 y squared times another y, integrated from 0 to 9, dy times 9800 pi. That integrated would be y to the 4th over 4 times 9, 36, times 9800 pi, evaluated from 0 to 9, and that would become just 9 put in there, divided by 36. One of the 9s would cancel that, but anyway, we'll just type it in. 9800 pi times 9 to the 4th divided by 36, and we get 561104142 joules. Okay.